Unit 15, Part 15. Do read through Klenk's introduction to this problem, 291. I read parts of it in the last section, Part 14. Right, and she says, transitioning from 290 to 291, so what should be our strategy? You should read through what she says, but the best way to work out this problem is to revert again to the method of working backwards. Look at the form of the conclusion, figure out what would be needed as a next to last step, and then what would be needed to get the next to last step, and so on, right? Which is her way of saying, or my way of saying that is always, what do? You remain conclusion driven, you look at the form of your conclusion, you figure out what rule you're going to use to derive that, and that also puts you in mind of, or leads you to the thought, what formulas do I need to apply that rule? And then you're aiming at that formula, and you ask yourself again, right, this is the then you say what would be needed to get the next to last step, and so on, the and so on, right? You repeat. So of that formula that you figured out you needed to get home, what's its form? Same thought again, right? What is its form? What rule gets me formulas of that form, right? Or where does that formula occur, plus or minus negation amongst the premises? How am I going to get it out of the premises? How am I going to arrive at that formula? And that's going to put you in mind of the rule you need and the formulas you need to apply the rule, and then continue on backwards, right? That's working backwards. Okay, what formulas do I need to get that second to last one? What is the nature of that formula? It's a conditional, do a conditional proof, whatever, okay? Working backwards till you see how to get what you need. So, applied here, my conclusion that I'm aiming for is a conditional. So, I'll set up for conditional proof, right? One is a universal statement. So, universal instantiation is sort of the obvious rule, but where and how it's going to be useful is not quite clear yet. Two is a conditional, so I'm thinking modus ponens, modus tollens, something like that. But let me say, okay, so it's a conditional, right? If I assume fx, if I assume what? So be clear here what the antecedent and what the consequent are. They are both quantifier statements, yes, they're both simple universal statements. The antecedent of this conditional is everything is f. And of course, as you know, when you're doing conditional proofs, you always put the consequent of the conditional you're trying to prove down the bottom, and that's essential because that's how you know where you're going, right? That's how you do the and so on, right? This is now the conclusion you know you need to get home, such that when you get this, you're entitled to infer this by conditional proof, right? It'll be what, 3 dash, I don't know yet, question mark, right? Step 3 is this. Repeat the mantra. Okay, everything is for all x, hx. That's the formula I need now. That's my goal, my telos. That's what I'm aiming for, okay? How do I get it, right? Okay, here is a very good example of how you need to avoid slipping into the habits you'll be in from doing the pure quantifier problems. The habits summarized in that table on 288, right? Those habits would lead you to think something like this. This is a universal statement, right? So, right, universal statements, you get them by UG, right? It is true that you do get them by UG. The avoidance of habit I'm encouraging is it's not always the case that you get them by UG. Sometimes other rules get you things like this, right? This is a universal statement, right? You might set up you derive universal statements, so the habitual thinking goes, you derive universal statements by universal generalization from a quarantined instance, right, that you derive within a UG subformula. So let me set up for that, because I'm supposed to do hard before easy rules. I'm supposed to set up for UG before I do any instantiations. So let me flag A, put HA down there. Right? Isn't that how I go about doing this proof? Wrong. Right? Because you've got a second premise here, which is not in quantifier form, which marks this as not a pure, that, as well as the negation, as well as the conclusion, excuse me, marks this as not a pure quantifier problem. Premise 2, if you grasp it as a conditional and and pay attention to what the antecedent and consequent are, indicates a different way of getting this conclusion, namely as a consequence of modus ponens, right? So this now is a thought that you only have by avoiding the habits you'll be in from doing the pure quantifier problems, right? Because look, for all x, hx, ask yourself this, right? So maybe do think the universal generalization thought is a possibility. Maybe I get this by UG, right? That's what I'm used to thinking, right? But maybe not. It's only possibly. It's only a possibility that's how I'm going to get this out. That's only possibly the right path. But also ask, right, this is the formula I need. Where does that formula occur? Plus or minus negation amongst the premises. Well, in this case, it occurs as the consequent of this conditional. Number 2, right? Well, if I get the antecedent of that conditional, then I can infer this by modus ponens, right? So you have to arrive at that as the other possible path. You have to see that, and you can only see that if you avoid the habits, right? Avoid the habits of the pure, of how you go about solving the pure problems, summarized on 288, right? So I'm working backwards, so maybe I'll get this by modus ponens. What do I need to get it? Of course, to apply modus ponens. Modus ponens is a rule that says if you have derived or are given a conditional and the antecedent of the conditional, then you're allowed to infer the consequent. So I've got the conditional, what do I need? I need the antecedent of the conditional. So what I need to infer this is for all x gx. For all x gx. That is the antecedent of 2, right? So you sort of have thought your way to a possible way you're going to use 2. Turns out to be the right way, right? This is a conditional. When I set up for conditional proof, I saw that I needed the consequent of that conditional. Once I have the consequent of that conditional in number 2, I'm home. I've got my proof. Okay, so I need to get to the antecedent. Okay, this is a universal statement. Again, a possible path to getting that universal statement is universal generalization, right? So would I be able to get, right, if I set up a flagging step for universal generalization, an A-flagged subproof here with GA as the instance from which to universally generalize to this, right? Facilitating then the modus ponens. Would I be able to in fact get GA? Could I derive it? Well, I've got, right, since when I set up the conditional proof, that gave me this as a formula that I have sort of derived, right? You can now basically treat what you assumed, this is your assumption, these are of course the premises. You can treat that as if you're given it as a premise, right? Because what are you doing? Conditional proof, you're assuming everything is F, showing that you can derive that everything is H, so that you can infer on the main line as absolutely true. If everything is F, then everything is G, right? Assuming everything is F, I show you that what follows from it is that everything is G, so if everything is F, then everything is, H. Okay, right? So I've got for all x fx, and remember number 1 is a universal statement. I can universally instantiate from that. I can see the way that I can get, in fact, GA, right? Now I say flag A, flagging step for UG. Crucial when you're doing universal generalizations, just like conditional proof, we put the consequent down here. Universal generalization, we put the instance here, GA. Right? I derive GA within this quarantined subproof. I I can infer that everything is G. Okay? And now it's just, notice that I have here done an application of hard rule before easy rule, set up for UG before doing universal instantiation. I'm going to do two universal instantiations now, right? Namely, F, A, hook, G, A, U, I, 1, F, A, 4, 5, 3, 4, 5, 6, 7, 8, 9, 10. This is universal instantiation on 3, right? And this is modus ponens, right? I've got a conditional